The Earth has been hurtling towards Jupiter for the past 242 days. And now, it's about to make impact. Now, we're so close to the giant planet that it's the only thing that fills our sky. Ground temperatures on Earth are rising uncontrollably. Our atmosphere is igniting into flames, and the scientific community is scrambling to provide answers. What will happen when the two planets collide? Is there any chance that we could pass right through the gas planet? And how would this collision transform Jupiter forever? This is What If? And here's what would happen if Jupiter swallowed Earth. One way that scientists could find answers would be by looking into the past, because this wouldn't be the first time that Jupiter has collided with another planet. Nearly 4.5 billion years ago, Jupiter was involved in a violent collision with a planet 10 times the mass of the Earth. In that case, the collision completely transformed Jupiter's core, but what happened to the other planet? And what can that tell us about our own planet's chances of surviving a crash into the gas giant? To get some answers, let's travel back to 4.5 billion years ago, when Jupiter was just a young planet trying to find its place in the universe. Back then, Jupiter's gravitational pull became 30 times more powerful in just a fraction of a million years. This destabilized the orbits of nearby infant planets and caused some of them to crash into Jupiter. It's believed that one such planet was 10 times the mass of Earth, and it was mainly a silicate ice core. The planet hit Jupiter with an impact speed of 46 kilometers per second. Jupiter only lost a small amount of mass from the collision, but its original core was completely changed. Before the impact, Jupiter had a dense central core of heavy elements, and the rest of the planet was made up of hydrogen and helium. After the impact, the infant planet's silicate ice core merged with Jupiter's, causing Jupiter's core to become diluted. The heavy elements spread out and mixed with the outer layers of Jupiter. While this collision was a defining moment for Jupiter, it meant the end of the road for the other planet. So, what are the odds that the Earth's fate would be any different? Well, let's find out. The Earth orbits around the Sun at an average velocity of 29.78 kilometers per second. At this speed, if the Earth were to just leave its orbit around the Sun and head straight for Jupiter, it would take about 242 days to get there. Throughout our journey, Jupiter would shine like a bright star, growing bigger day by day, hour by hour. By day 6, Jupiter would appear as bright as our moon. Soon, we would start to notice our daylight becoming dimmer. We'll only get about 50% of our normal sunlight when we reach Mars's orbit. Luckily for us, the Earth's atmosphere would act as a buffer, so we wouldn't experience the cold right away, but that will only last a while, so you'll need to invest in some heavy-duty winter gear. To put it in perspective, Mars has a surface temperature of minus 63 degrees. So that's basically what we'd have to look forward to. Once we speed through Mars's orbit, we'll pass through the asteroid belt. We'll get to see beautiful meteor showers lighting up the sky, but we'll also be at risk with colliding with some of those meteors, so let's keep moving. After 242 days of traveling through our solar system, we would finally reach our destination, Jupiter. As the Earth is pulled into Jupiter, our planet's velocity could increase until it reaches 60 kilometers per second. That's 250 times faster than an airplane flies, so you'll want to hold on tight. Oh, and did we mention that Jupiter has 79 confirmed moons orbiting it at all times? So there's a serious risk that we could collide with any of them as the Earth is pulled in closer. And if we do happen to avoid all those moons, things would only get worse. As we crash into Jupiter, both planets' atmospheres will be compressed, rapidly increasing the temperature and essentially setting the air on fire. But at least we won't have to worry about colliding with Jupiter's core, because we'll never make it there. Our planet is too small and would burn up in the atmosphere before that ever happens. But this would have a huge impact on Jupiter, as the Earth's remains would completely mix into its atmosphere. So if you ever notice our planet going off course and heading towards Jupiter, you might want to jump off along the way. Something incredibly strange is happening. A mysterious gravitational disturbance is altering our solar system. Jupiter is now on a crash course with the Sun. What happens when one gas giant collides with an even more gigantic one? How would Jupiter journey to the center of the solar system? Would the Sun become even bigger and more powerful? And how might this be a life-threatening situation for us here on Earth? This is What If, and here's what would happen if the Sun swallowed Jupiter. Okay, before watching the greatest collision in our solar system's history, it'd be good to explore a couple of the ways this event could unfold in the first place. In order for Jupiter to crash into the Sun, something truly extraordinary would need to happen. Its orbit would need to be drastically altered by a gravitational disturbance. And not just any disturbance, an absolutely massive one. The most likely culprits would be a rogue star or a black hole passing dangerously close to our solar system. And these objects would have to be really huge. At the very least, they'd need to be a couple times more massive than our Sun. As they drift through interstellar space, they'd eventually interact with Jupiter's own gravitational field. And considering that Jupiter is about 318 times more massive than Earth, its gravitational field is an expansive one. And whether this rogue star or black hole tugs it in one direction or transfers a bunch of kinetic energy, it would make Jupiter's orbit increasingly eccentric. But there's a pretty big catch here, though. Somehow, those gigantic rogue objects would have to pass by at the exact right moment. A moment where they would only impact Jupiter. Otherwise, it wouldn't be the only planet in our neighborhood careening out of orbit and toward an imminent heat death. After a few billion years of orbiting the Sun at an average distance of 778 million kilometers, Jupiter would begin its death dive toward our star. But this wouldn't happen overnight. It could take years, decades, maybe even centuries. The gas giant would need to travel this incredibly vast distance, accelerating faster and faster under the immense pull of the Sun's gravity. This process is known as spiraling orbital decay, and it would result in Jupiter orbiting in tighter and tighter spirals until, well, it reaches oblivion. The next phase of this planetary destruction would occur when Jupiter would be close enough to be torn apart. This is known as the Roche limit, and for a body as big as Jupiter, it would begin when it's just under 900,000 kilometers from the Sun. At a distance this close, the planet would become tidally locked, just like Mercury is. This means that it would only make one full rotation on its axis for every full rotation around the star. But for that to occur before the planet starts to disintegrate, its rotation speeds would also need to undergo significant changes. Currently, Jupiter makes one full turn every 10 hours. But to become truly tidally locked at this distance, it would need to more than double its rotation speed. If this were to happen, only one side of Jupiter would ever fully face the Sun. And each of the two sides would experience varying levels of gravitational pull, with the day side or near side getting stretched out more and more. Jupiter would no longer resemble a gigantic gaseous sphere. Instead, it would have a more oblong, elliptical shape. You can almost imagine Jupiter going through the process of getting spaghettified, like what happens when an object crosses over the event horizon of a black hole, though this would be slightly less extreme. But that doesn't mean it's not the end of days for our biggest neighbor. Its atmosphere would be getting stripped away, forming a glowing ring of dust and gas around the Sun. This is called an accretion disk. And this is where Jupiter's existential plunge would get really interesting. Both the planet and the Sun are mostly made up of hydrogen and helium. So as Jupiter gets absorbed, would the Sun get bigger and more powerful? Well, considering that our planet is already warming at a dangerous pace, this could trigger some alarm bells for you. But don't worry too much. This collision isn't about to change much in terms of the Sun's energy output. As big as Jupiter is, it's only about 0.1% the mass of the Sun, so we're not talking about a hugely noticeable difference. For a short amount of time, the Sun would be a bit brighter as it converts all of Jupiter's energy. This would be the first effect that this whole scenario would have back here on Earth. You'd be treated to a little extra sunlight during the day, and the night sky would be a bit brighter as you watch Jupiter's final days before it vanishes into the Sun. The biggest effect would come from the gigantic gravitational hole that Jupiter would be leaving in our solar system. For billions of years, it acted as a so-called cosmic vacuum cleaner by attracting comets and asteroids of all shapes and sizes. Without its presence, Earth would find itself exposed to dangers in entirely new ways. The chances of impacts from large objects known as planet killers would become higher. And that would be one of the greatest existential risks for all life forms on our planet. But odds are just odds, right? We could always find ourselves in the flight path of one of these cosmic objects. I wonder which ones we should be most worried about. It's almost as old as the universe, and as massive as 34 billion suns. It eats stars for breakfast. And now it's about to consume ours. Behold, the great and powerful black hole with the catchy name J2157. If it came close enough to our solar system, how fast would it destroy us? How would it all go sideways for our Sun? And how exactly would this monstrous black hole end all life on Earth? This is What If, and here's what would happen if a black hole swallowed the Sun. Black holes are scary enough. They form when big stars explode in a supernova and then collapse in on themselves. The most common black holes, the stellar ones, are only 16 kilometers in diameter, but they have the mass of a star at least 10 times more massive than our Sun crammed in them. All that mass compressed into such a small diameter makes black holes extremely dense. If you came too close to a black hole's vicinity, beyond its event horizon, its extreme gravitational pull would turn you into a spaghetti noodle. But there are black holes so massive that they make stellar black holes look feather light. These are called supermassive black holes. These monstrosities lurk at the centers of galaxies and take up space roughly the size of our solar system. But most of them don't even get close to the size of black hole J2157. J2157 is the fastest growing black hole in the known universe, and it's the second largest one. Its event horizon has a radius of 670 astronomical units, which is comparable to the distance between the Sun and Neptune multiplied by 22. Whoa! If that's not scary enough, J2157 holds the title of the hungriest black hole we know. To stay in good shape, it gobbles up matter at a rate of about 1 sun per day. Now, take this monstrosity and bring it closer to our solar system. You can imagine how that would play out. If J2157 could replace the supermassive black hole that sits at the center of our Milky Way galaxy, to us on Earth, it would look 10 times brighter than the full moon. That's because of its incredibly large accretion disk, the matter the black hole collected on its way to us. And because it always needs to be the center of attention. This monstrous black hole would outshine most of the stars in the sky. If a black hole under 100 million masses of our Sun entered our solar system, it wouldn't swallow the Sun in one go. It would gradually start pulling matter from our star until all that's left of it would be a cloud of gas. In that case, you could expect lethal amounts of cosmic radiation headed toward the Earth. But that's not how J2157 likes to deal with things. A black hole of that size and mass would devour the Sun in a moment. But losing the Sun would be the least of our problems. Our planet could be torn apart by the tidal forces from the black hole consuming our Sun. Or it could be bombarded with an unthinkable amount of cosmic radiation. Or it would disappear into the black hole's event horizon, along with the rest of the solar system. Either way, you wouldn't get out of this alive. But no matter how big and scary J2157 is, remember that it sits at a safe distance of 12.5 billion light years away from us. I'd say we're pretty safe here. The Sun's core is shrinking, but as its core shrinks, the Sun itself grows larger. And it will continue to grow until one day, it engulfs the Earth. How long can you survive? What will happen to the oceans? And will other planets be affected? This is What If, and here's what would happen if the Sun swallowed the Earth. Every 1 billion years, the Sun becomes 10% hotter. But here on What If, we're going to take billions of years and condense the action into 1 month. Get ready, because we're going to be moving really fast this time. Instead of 1 billion years, it would only take 4 days for the Sun to become 10% hotter. This means you'll see the Earth engulfed by the Sun in just 1 month. That is, if you're still around to witness the final event. On day 1, you'd be blissfully unaware of the tragedy about to befall Earth. Maybe it's a little hotter, but that's just weather. It happens. But by day 4, space agencies across the globe would be sounding the alarm bells. By this time, the Sun would be about 10% brighter and hotter. And while 10% doesn't sound like a lot, it will be the beginning of the end for us. As the sun heats up, more and more water from Earth's surface will evaporate into the atmosphere. This will increase the greenhouse gas effect, causing global temperatures to skyrocket. All of a sudden, it will become very humid and very hot. But the sun's high-energy light would bombard the atmosphere, splitting those water molecules into hydrogen and oxygen. Earth will begin to lose its water, and you won't be able to escape the lethal radiation on Earth's surface. If you want to survive, you'll have to go deep underground. But even under a protective layer of Earth's soil, you won't be safe for long. By day 16, the sun would be almost 40% brighter. Our planet's oceans will boil, and there won't be any moisture left in the atmosphere. The beautiful, lush Earth that you grew up on will become a hot, dry, barren rock. Around day 20, the sun would run out of hydrogen, so instead, it will start to burn helium in its core. The sun is now a red giant star and would expand rapidly while losing its mass. The sun's gravitational pull on Earth would be weakened, and our planet would begin to drift away from the expanding sun. But not far enough. According to researchers Klaus-Peter Schroeder and Robert C. Smith, the Earth would only have moved about 0.0002 astronomical units. An astronomical unit is the distance between Earth and the Sun. While Earth is moving away from the encroaching Sun, the red giant would grow up to 1.2 astronomical units in radius. The Sun would be larger than Earth's orbit. It would swallow the planet whole. Once it's inside the Sun's atmosphere, Earth would collide with particles of gas and spiral inward. And Earth wouldn't be the only casualty of the expanding Sun. Mercury and Venus would be vaporized. The rings of Saturn would melt. Pluto would become much warmer. And if there is a liquid surface and a thick atmosphere on this distant dwarf planet, it might even become inhabitable. Unfortunately, 30 days doesn't give the human race enough time to prepare for such a catastrophic event. But if we had more time, like billions of years worth, we could come up with an evacuation plan. These balls represent one of the strangest phenomena currently taking place in our universe. Each ball symbolizes one of the 100,000 galaxies, including our own, that are currently being pulled towards a mysterious point in our universe called the Great Attractor. We can't see exactly what is pulling us there, but the only force that would be capable of doing so is gravity. So, whatever is out there, it's massive and unrelenting. How far away is the Great Attractor? What happens when our galaxy gets pulled into it? And will we ever be able to see the source of its power? This is What If, and here's what would happen if the Great Attractor swallowed our galaxy. Going back to our ball example, you can see that if you have 100,000 galaxies all moving towards the same destination, the odds are that some, if not most of them, are going to collide with each other. And if you've been watching our videos, you probably know that almost every one of those galaxies would have a black hole at its center. So, what can we expect to happen when nearly 100,000 black holes merge with one another? Before we get ahead of ourselves, let's get to know these 100,000 galaxies a little better. Our galaxy, the Milky Way, belongs to a group of a few dozen galaxies called the local group. Cool. Just like the sun's gravity pulls the Earth toward it, our galaxy is pulled towards the other galaxies in our local group. Our local group belongs to an even bigger collection of galaxies called the Virgo supercluster. And this supercluster belongs to an even larger supercluster known as Laniakea. The one thing all these clusters have in common is that they're all being pulled towards one specific spot, 220 million light years away, known as the Great Attractor. Its vast distance away, coupled with all the gas and dust that surrounds it, has made it virtually invisible ever since its discovery. Until now, thanks to X-ray and radio astronomers, we can now see behind this cloud of gas and dust. So now we know that this Great Attractor is really just another supercluster named the Norma supercluster. Norma has the mass of about 1,000 trillion suns, which might explain why it's so attractive to these 100,000 galaxies. So now we know where our galaxy is heading and why we're heading there, but what could happen along the way? Well, for one thing, we could collide with another one of the 100,000 galaxies heading that way. The most likely one being our closest neighbor, Andromeda. If these two spiral galaxies collided, they would merge into one new elliptical galaxy. During the collision, vast clouds of hydrogen would become compressed and rapidly create new stars. This would result in the premature aging of the new galaxy as it used up its fuel. That doesn't seem too bad, but that's because the black holes in the center of these galaxies haven't collided yet. When these two black holes merge, it will release energy equivalent to 3 times the mass of our Sun within a matter of seconds. That would be enough power to create a disturbance in the space-time continuum. And that's just 2 black holes colliding. If all the black holes of the 100,000 galaxies drifting towards the Great Attractor merged together, it would release more energy than we could ever imagine. But luckily we won't have to worry about that because these galaxies will probably never arrive at the same spot and collide. You see, the Great Attractor is also being pulled deeper into space by other massive clusters. And these 100,000 galaxies are also constantly drifting apart, further away from each other. The universe is constantly expanding, and that expansion will be stronger than even the Great Attractor's pull. What will eventually happen is that Laniakea itself will come apart, and all the galaxies within this supercluster will start to drift even further apart. So there's no big collision, no humanity-destroying event to end this episode, just a bunch of galaxies drifting off into the abyss. You start your day hearing wild news. Jupiter has just swallowed Saturn. And it doesn't stop there. Jupiter is on its way to swallow every planet in the solar system. How big would Jupiter get? What would you see from Earth? And would Jupiter get rings like Saturn? This is What If, and here's what would happen if Jupiter swallowed every planet in the solar system. Jupiter has swallowed a planet before. Around 4.5 billion years ago, a protoplanet slammed into the young Jupiter. The protoplanet was 10 times Earth's mass, made of rocky and icy material. Jupiter's core broke apart and denser material mixed with hydrogen and helium. A few billion years later, the heavy material settled back into the dense core that we see today. Now, swallowing a single planet is one thing, but could Jupiter eat up all 7? In this scenario, you're going to see the planets get swallowed from largest to smallest, although we're saving Earth for last. Jupiter's first victim would be Saturn. From Earth, you could see these gas giants as 2 bright stars. And if you were to look up at the night sky as Jupiter swallows Saturn, well, all you'd see is Jupiter getting super bright. But if you were closer to the action, you'd see complete chaos. Jupiter is only 3 times heavier than Saturn, so it would be swallowing a planet that's almost its size. First, their moons would collide, creating massive amounts of debris. Some moon remnants would rain down on Jupiter, and some of the debris would float in space. As Jupiter was crashing into Saturn, Jupiter's surface temperature would become hotter than the Sun's outer layer. Whatever remained of Saturn would mix in with Jupiter's atmosphere. They would become one. Now, swallowing Saturn would increase Jupiter's mass and gravity by 30%. Jupiter would also sport prominent new rings from the shattered moons. Next, it would envelop the 2 ice giants, Uranus and Neptune. The 27 moons of Uranus would collide with the rings of Jupiter, adding to the floating debris. Uranus has an icy core made of water, methane, and ammonia, but Neptune's inner core is rocky. Regardless, both cores would melt as the planets crashed into Jupiter. Now, Jupiter would be almost 40% heavier, and it would head towards its first rocky planetary snacks. The rocky planets, Venus and Mars, wouldn't even make it to Jupiter's core. They'd burn up in Jupiter's atmosphere as if they were mere asteroids. Then we'd see our last planetary neighbor disappear inside this bulked-up Jupiter. Mercury is even smaller than Jupiter's largest moon, Ganymede, so it would get ripped apart by Jupiter's rings, adding to the speedy debris. Now, only Earth and Jupiter would be left, and Earth would be in big trouble. But how would Jupiter go about swallowing our planet? Even in its normal state, without swallowing 6 planets, Jupiter's gravitational force affects Earth. Yeah, every 405,000 years, the pull of Jupiter and Venus makes Earth's orbit wobble. It causes hotter summers, colder winters, and more rainfall in the tropics. And now, Jupiter's gravitational pull would be over 40% stronger. But Jupiter's pull would still be no match for the Sun's gravitational force, so Jupiter would have to come for Earth just like it swallowed all the other planets in our solar system. Jupiter doesn't have a hard surface like the rocky planets. You could say Jupiter is a big, dense ball of gas. Its surface is defined as the point where its atmospheric pressure is equal to Earth's. Well, so could Earth simply pass through? No. Just like the rest of the planets, Earth and all life on it would be toast. First, we'd be bombarded by asteroids while passing through Jupiter's rings. I doubt anyone would survive this, but if they did, they would see the Earth igniting as it enters Jupiter's atmosphere. Jupiter is so massive that even if it were to swallow its 7 planetary neighbors, it wouldn't even double in size. Now, what would happen if Jupiter continued to grow? Well, even if Jupiter increased its mass by 400%, it would stay about the same size. But the extra mass would make Jupiter so dense that it would start pulling in on itself. Yeah, it would get smaller instead of larger. And if Jupiter were to increase its mass by 70,000%, well, it could trigger a fusion reaction and light up like a star. Can you imagine what it would be like to have not one, but two stars in the solar system?
They're massive and extremely dense. They rip apart anything and everything that gets close to them. We can't see black holes, but we know they have the destructive power to wipe everything out of existence. This is What If, and here's what would happen if a black hole deleted the universe. Before we get to the part where a black hole erases the universe, let's make something clear. The universe is a giant supercomputer processing information. Without information, there can be no universe. But what is information? In physics, information is the property of a specific state of a particle. I know, it sounds confusing. Here's a simpler way of looking at it. This is a carbon atom. A bunch of these can be arranged to make a hard diamond. But if you change the arrangement of atoms, you can get soft graphite. The basic building blocks are the same, it's information that makes them different. In quantum mechanics, information is like energy. It can't disappear into nothingness. So how, in the universe, can one black hole do the impossible? That's the black hole information paradox. Black holes act like monstrous cosmic trash compactors. They squeeze stars, planets, and unfortunate astronauts who cross the event horizon into a microscopic point. So, what happens to the information about every particle that a black hole consumes? Since information can never be destroyed, it has to be stored somewhere inside that black hole, right? Our original understanding of black holes assumed that everything that disappeared in the black hole stayed in the black hole. The moment an object passed the event horizon, it got crushed into the density of the black hole. The information about it could never be retrieved again. That's what we thought before Stephen Hawking introduced Hawking radiation. Hawking realized that black holes aren't static. Rather, they release their mass and energy back into the universe, particle by particle, until there's nothing left. So, does that mean the information within a black hole can somehow escape with the black hole's outgoing radiation? Not quite. The black hole doesn't preserve the information it consumes, it chaotically mixes it together with other bits of information, making it impossible to recover. The information is lost forever. If the information can be lost, that would mean that black holes can eventually delete the universe. Forever. But there is a possibility that the black hole doesn't delete the information. It may be hiding it in a baby universe, a small, self-contained part of the universe that branched off of ours. The information wouldn't technically be lost, but we wouldn't be able to interact with it. Another possibility is that black holes can encode the information, according to the holographic principle. If you were to get trapped inside a black hole, you'd still experience three-dimensional space. For us, looking at you from the outside, you'd appear stretched on the flat surface, just like a hologram. That would mean that the information paradox is resolved, and we don't need to rewrite the laws of physics. But we'd have to rethink our understanding of reality. The universe could be a three-dimensional image projected off a two-dimensional surface. And you may be a hologram on the surface of a black hole. And the best part? The black hole couldn't delete the universe after all.
It's been 30 days since Uranus first appeared in the sky. At first, it looked like our moon had found itself a stellar partner. But then we understood something much, much bigger was headed our way. What caused Uranus to become so unstable? How could this epic collision change the ice giant? Oh, and what's this horrific stink? Ugh! This is What If, and here's what would happen if Uranus collided with Earth. Let's roll back 30 days, when things were still normal. Uranus lived a quiet life on the outskirts of our solar system, about 3 billion kilometers away from us. And then suddenly, it began to move closer. Astronomers would be the first to push the panic button. By their calculations, it would take Uranus 13 years to reach the collision point. We'd be short on time, but at least we'd have a slight chance to evacuate the Earth. But the cold blue giant had other plans in mind. This would be no standard planetary drill. Planets don't just take off from their orbits for no reason at all, but somehow Uranus did. Now it would be hurtling through the solar system, ramping up to a speed of around 1,000 kilometers per second. Because of this unexpectedly fast speed, we'd only have about 30 days left on this planet. Uranus would shine like a bright blue star in the sky, and every day it would appear bigger and brighter. Our sky would look gorgeous, not only because of the ice giant shining down on us, but also thanks to many shooting stars. Only those wouldn't be stars at all. To get to the Earth's orbit, Uranus would have to pass an asteroid belt between Jupiter and Mars. This would disrupt the stable orbits of many asteroids and throw some of them our way. These asteroids can be as big as 240 kilometers in diameter. That's a few times larger than the one responsible for wiping dinosaurs off the face of the Earth about 65 million years ago. We would have nowhere to go. We'd just be left here, watching the end of times unfold in front of our eyes. Might as well enjoy the view. By the time the first asteroids appeared as shooting stars, Uranus would look about the same size as the Moon, but it would be growing rapidly as it moved ever closer. While you'd be here awaiting humanity's doom, Uranus would start shaking things up. Because Uranus is about 15 times more massive than the Earth, its gravitational pull would start massively affecting our planet. Volcanoes would begin erupting uncontrollably, and tremendous earthquakes would get in on the act, destroying the Earth from the inside. And the stink. You'd drop unconscious from even one whiff of it because, Uranus smells like farts. The ice giant's upper atmosphere is mostly composed of hydrogen sulfide. It's the same stuff that makes rotten eggs reek so bad. Imagine an entire planet of rotten eggs engulfing the Earth. Blech! The thought of it makes me nauseous. But Uranus wouldn't come alone. It would bring all of its 27 moons along for the ride. And those moons would be hitting the Earth from all sides. As a fart-filled finale, Uranus would compress what was left of our atmosphere, and the rapidly rising temperatures would ignite it. Just like that, our beautiful blue planet would fall in line and start circling the ice giant, eventually becoming one of its many moons. Uranus wouldn't get away with this assault so easily, however. Last time it collided with another planetary object twice the size of Earth, it tipped over. Yeah, Uranus is the only planet in our neighborhood that spins on its side. This impact, featuring our earthly home, could help tilt it back to how it once was. But for the Earth, we know that would be it. If by some unexplained mystery, life on Earth's stinking leftovers emerged once again, we would see the blue of Uranus on the horizon. It would look just as cool as if the Earth was one of Jupiter's moons. This pretzel-shaped collection of galaxies is our universe. And it's about to collide with another universe. It might be fascinating to watch, but we should probably be worried about what's going to happen when they crash. How would it change the physics of our universe? Is there any chance that we would survive? What would the collision look like from Earth? And has it ever happened before?
This is What If. And here's what would happen if our universe collided with another one. The only potential evidence of a universal collision that we've ever discovered is in the form of a cold spot in our universe. In 2013, the European Space Agency's Planck satellite confirmed that this area is 1.8 billion light-years across. It's much colder than the rest of space, and it seems to be missing 10,000 galaxies. At first, scientists were baffled by its existence, but now some have theorized that this spot might be a kind of scar or bruise left from colliding with another universe.
But how can we know for sure? And if this is the case, how long before it happens again? Before we go any further, let me take a second to address something that might have some of you scratching your heads. Usually, when we refer to the universe, we're talking about all space and time, including planets, stars, galaxies, and all other forms of matter and energy. So, if the universe basically means everything in existence, then logically there can only be one of them, right? Not necessarily. Some scientists believe in the concept of the multiverse. This theory states that our universe wasn't the only one that popped into existence during the Big Bang, that there's an infinite number of other universes out there too, and we just haven't found a way to see or measure them yet. If this theory is right, then it's possible that all these other universes could have grown at the same rate, at the same time, after the Big Bang. If that's the case, then
They might have banged into each other as they expanded. And that brings us back to the cold spot. The cold spot is a region of our universe that's 0.00015 degrees colder than everywhere else. That might not seem like a big deal, but when the rest of the universe's temperature is so consistent, scientists have started to think it's something more than an anomaly. They think that the cold spot might be a scar left over from a collision between universes. And the crash might have moved a bit of energy out of that spot in our universe, causing the colder temperature. But what would a collision of that magnitude look like? Well, we can't say for sure, but there are some pretty cool ideas out there. According to one physicist at the University of California,
if another universe came crashing into ours, it would look like a giant mirror in the sky rushing towards us, because its wall would reflect light. If this other universe collided with our own, we could inherit a whole new set of governing laws of physics. Gravity could weaken or disappear, resulting in a slew of planets escaping the gravity of their stars, sending them flying off into space at ridiculous speeds. Without gravity, stars would cease to exist, and we'd be left in perpetual darkness. This would make life on Earth, and throughout most of the universe, nearly impossible. With no shining stars, we'd lose any means of nourishment or breathable air, as plants would no longer be capable of transforming starlight into energy through photosynthesis. But as bad as that all sounds, it's not something we really have to worry about, since the chances of our universe colliding with another one are slim to none. For one thing, we're not even sure that there are other universes out there to collide with. And even if there are, any collisions would have happened at that point when they were expanding, 380,000 years after the Big Bang, which would mean there's little to no chance of it happening again. If you're going to worry about colliding with anything, maybe you should pick something a little more realistic, like an asteroid. But that's a story for another What If. The Earth has been hurtling towards Jupiter for the past 242 days. And now, it's about to make impact.